All right. So how do I get rid of this video thing that is coming up here?
Oh, is it showing you your own screen?
Yeah. So I'm
I
stopping
think
my
there's a
own
little
video.
collapse window. We'll edit this out, don't worry.
All right. All right. Now it's at least a smaller portion. All right. Thanks everyone for taking the time. This subject for our conversation for next few minutes, it's going to be the way we can build the logistics digital twin. Before we get started into the content, I just wanted to make few disclaimers. I am coming here into this community of AWS users in the capacity of an individual essay. Anything, any content, any architectural pattern, any devices, any applications that I propose or I use in my architecture is by no way can be construed as an AWS recommended way of architecting a solution. I just wanted to make it very clear. The sole objective of this session is for me to share with you what I have learned as an art of possible in order for someone to leverage the open source and some homegrown technologies to build the digital twin and solve some pretty solid logistics problems. So unless somebody has any question, I can just get straight away started into the conversation. So my name is Kartik Mehta. I'm a partner solution architect with AWS for supply chain and logistics. I've been with AWS for about 3.5 years, and I'm based out of Chicago office. I spent my career on supply chain planning and execution, so I consider myself to be a supply chain professional who also happens to be the cloud architect. So having said that, I'll just straight away get into the content, and I will put the content into the slideshow format. And please let me know if anybody has any difficulty in viewing my desktop right now. So what is the knowledge graph?
Sorry, do you want questions as they come up, or do you want us to save them to the end?
That's a good point. Please raise the question. I want this session to be interactive. If you believe that there are certain points that needs to be given more emphasis, or there are certain points that needs to be moved fast, please be more interactive. I don't want this to be a lecture. I want this to be an interactive session where I also get to learn from you guys as well. So I'm just one of you guys. I'm just trying to show you the art of possible, the way you can exploit the technology to build the logistics and knowledge graph. So please be vocal and ask me any question and interrupt me in the middle of the conversation. So what is knowledge graph? So if you look at any enterprise, the data is spread across all supply chain silos. Like generally the supply chain constitutes plan, buy, sell, plan, buy, make, move, and sell. Across all these supply chain silos, different systems, different homegrown systems, different databases are being used to capture the data from the transactional systems itself. But there are no relationships built into it. So if you fire a query on just raw data, which is hidden into the columns and rows, it's very difficult to understand the business semantics, the business relationships on top of it. So knowledge graphs allows us to understand the underlying data and build the relationships. In a technical term, it builds the classes and subclasses that is reflective of the business concepts within my transaction processing system. For an example, location is a business concept. In a logistic terms, the lane is a business concept. The source location, destination location, item, lane capacity, lane mode of transport, these are all business concepts. And how do those business concepts relate to each other is what knowledge graphs allows us to understand. So it's simply adding a semantic layer on top of the relational data in order for the decision makers to make the decisions without firing a very complex queries on top of it. And as I said, please ask me question as I speak. I don't have any visibility into any text question that you might have raised, so please voice it over.
I'll keep an eye on chat too. If anyone wants to type rather than talk, I can be your voice.
Please, Margaret is there. So if you feel like, if you prefer to type a question, please do so as well. Thanks, Margaret. So let's just talk about the benefits of using the knowledge graphs. What are the specific use cases where the knowledge graph becomes pretty useful? So as my cursor moves, you have a bunch of spreadsheets, your ERP systems, your manufacturing execution system, CRM, some homegrown systems. Oh, I'm sorry. All these transaction processing systems have the data in their own silos itself. Now, if data residing in those silos are exposed to this kind of use cases, where the use cases requires the data to be combined from disparate systems across different silos, or you need to find a common path or common connections among different business concepts, where there are many to many relationships all across your transaction processing systems or any sources of data itself. In those cases, the knowledge graphs allows, as I said, to understand the relational concepts from the relational data sets and build the ontologies on top of it that connects the business concepts with each other. And that's where the logistics knowledge graph comes into play. And then you can build the custom applications on top of it. And I'll go into the greater detail in a few minutes. So this shows, the last slide was showing, what is the usefulness of, what are the specific business use cases where I can leverage logistics or any knowledge graph. I'm using logistic knowledge graph because a very small segment of supply chain that I've tried to exploit to build this knowledge graph. But it can be leveraged across entire silos, like entire supply chain, from manufacturing to distribution to logistics to warehousing as well, including even the procurement on the back end of the supply chain as well. So what are this? I mean, this simply gives, like, if somebody asks you a question that what actually is the knowledge graph, so this actually gives us a pretty good way of explaining it. Like if this is my manufacturing facility, this is my manufacturing facility, and this is my distribution center, for an example. If I want to find out that how does this distribution center gets affected if this plant goes down, okay? So if you look at the relational data sets, you will have to fire a pretty complex queries to understand this. Whereas in knowledge graph, all the business concepts are being connected through the relationships, through the semantics, and it brings back the information so that any business user who wants to understand that if I want to know what are the impacts of closing or opening a specific business unit or a plant, this is the impact. And very good example is also Facebook example, that if I am a friend with Margaret and Margaret is friend with someone else, if I want to find out that how am I friends, how deep I am with that person that Margaret is friend with, that's how we can just do the hopping across the connections and find out this is how I'm related. So semantic layer actually allows us to create few hop and find out an answer to the question. And this logistic knowledge graph that I'm showing here is my end goal. The one that I have created is nowhere near there right now, but this is the service. This is the logistic service that I want to build in near future, as I'm in the process of making it happen. And this is my end goal. So the entire knowledge graph is going to be based on this kind of a knowledge set that allows the supply chain planners and analysts to really make the decisions. And I'll show you exactly how it means. What is the process of creating the knowledge graph? Generally, you have a relational database systems like my SAP, Oracle, Infor, manufacturing execution systems. All of this transaction processing system where my data resides, where my business intelligence actually resides, is in an RDBMS format. So we simply explore the RDBMS, understand that out of all the RDBMS schemas like my SAP transportation management systems, Oracle transportation management systems, some Salesforce related data, which RDBMSs are more rich in terms of metadata space that gives me greater semantic layers. And I'll show you how do we make that happen. So if I have multiple RDBMS systems which are reflective of my transaction processing system, we will expose them to a custom algorithm that tells that based on the data and the tables that you have selected, the richest source of metadata, the metadata richness is there in this specific source of data. And how do we make that happen? I'll show you. So when I say metadata space richness, means that which data sets has more primary key and foreign key well defined, which data sets have the constraints within the fields more defined. Like for an example, certain fields have a default value. Certain fields have only integer or a real value. All these constraints are analyzed, and based on that, it comes up with a scores and tells me that the richest metadata space belongs to this specific RDBMS or this specific transaction processing system. Once you find out the metadata richness within the RDBMS, we expose them to a specific algorithm that is an open source W3C standards that extracts the RDBMS data and creates the ontology on top of it. And that ontology can be exposed to the external world for the entire supply chain community to add their own concepts and make the ontology richer. Because every RDF object within the ontology, I'll show you what I'm talking about, is actually, oh boy, I'm sorry. I'm sorry.
The joy of Chime, it calls you.
Joy of Chime. Joy of doing. So you extract the RDBMS data and expose them to an open source tool called RDB2Onto that I'll show you. That is based on the W3C standards that understands the richness of the metadata and converts the RDBMS relationships into the ontological concepts. And I'll show you how to make that happen. And then each element, each resource within the RDF is actually a URI. And that resource, that URI can be exposed to your trading partners for them to add their own objects for this ontology in order for the entire ecosystem of partners to be exposed to a single ontology. And I'll show you what I mean.
Can I ask you a question? I mean, when I'm seeing knowledge graph, I'm thinking graph database, and there may be all kinds of reasons not for that, but I mean, I'm thinking about Neptune.
Right. So ontologies are a W3C standards. It was invented by Google in 2012, and it was based on the fact that the RDBMS data is not very conducive or very easy to understand for the business users. All the data in tables and rows. I'm sorry, the columns and rows. So they invented the ontology whereby the business concepts are connected with each other. For an example, if I have to find out from an ontological, and I have an example in the next few slides. I would request that we park your question, and then I'll show you the difference between ontological schemas and RDBMS schemas, and where does the Neptune as a graph database come into play, because we also have a part of Neptune in the conversation itself.
Yeah, carry on. Thank you.
Okay, so I'll make sure that I address your question at the appropriate time. So this is the logistic knowledge graph. I call it to be a graph analysis tool, a GOAT. So this simply represents the way I have made this happen. Now, this is actually the manifestation of the concepts that I just highlighted a few minutes ago. So these are my transaction processing system, ERP, manufacturing execution system, CRM, and I expose them to a custom design engine. Just imagine that there is a custom design engine that translates these RDBMSs into a knowledge graph and into a graph data. Knowledge graph for visualizing the ontology in a graphical format, and graph data to query the graph and find out the intelligence on top of it. And then once the knowledge graph is there, we are going to use an open source graph visualization tool to look at the graph in a graphical format. And then we will use the Neptune Jupyter notebook to query the graph data and understand what those graph data are. And once the data is there in the graph data in the Neptune, you can use that data to spin up a machine learning experiment. For an example, if the graph data sets are exactly the features that I need for my machine learning experiment, then you can use that and spin up a machine learning experiment right there from the Jupyter notebook using SparkQL in Neptune. And I'll show you how to make that happen. Or if these graph data are actually an input to a bunch of microservices that you use to build some custom applications like my response planning, supply chain response planning, or supply chain supply planning kind of a thing, where this graph data becomes an input to it, you can simply extract the graph data and send it to a microservices as an input for a custom application to be built. Now, this custom design engine, how have I made that happen? I'll just explore that now. So, you build a custom application whereby you identify which tables from this ERP is relevant to your specific use case. For an example, for us, if I want to find out that I want to know which transportation lanes are using capacity more than what I have the availability, then I will extract only those tables from ERP, manufacturing, and CRM, which are applicable to my use cases. And then we expose them to this enhanced custom engine that I'm going to describe in next few minutes. And then we create a knowledge graph, and then we query the graph data. And I'm not going to repeat the same thing again. Moving on. So if I explode this enhanced custom engine, this is how it looks like. So what I have done, that I have created 3 schemas in MySQL RDBMS. And these schemas that I have created in RDBMS are reflective of 3 different transaction processing systems. For an example, let's just say that for the use case that I'm trying to solve, I have my data in SAP Transportation Management System. Some of them are in my custom applications and some of them are in my CRM applications. So I have an RDBMS as a demo that I'll show you, where different schemas are reflective of different tables and different richness of the metadata underlying those tables itself. I will expose them to the custom algorithm in Python that I have written, which will look at these data sets in the MySQL as a reflection of my transaction processing system. Will calculate the semantic score based on the algorithm. And the semantic score, the highest semantic score, is going to be exposed to an open source tool called RDB2Onto, which will create an OWL file, web ontological language, which is a W3C standards. And it will also create an RDF. So OWL file, where my cursor is for the visualization of the graph, and RDF is where the data within the graph reside. And we will use Neptune graph to query the data and possibly use them for the machine learning. And we will use the OWL for the visualization of the graph using web OWL as an open source ontological visualization tool. So this is what we are going to do. We will have few schemas that will expose them to custom algorithm and understand the semantic richness of that source, and then we'll expose that richest source of information to RDB2Onto. We'll create the graph, we'll extract the data from the RDF through the Neptune, and then I'll show you the way you can use the same data to spin up the machine learning model within the Neptune graph itself using SparkQL. Okay, so and this shows the RDBMS. So my transportation management system has this kind of a logistic network. This is the definition of logistic network in my transportation management system. For an example, there are a bunch of locations, and there is a lane. Lane is an origin plus destination. I have a sourcing logic defined that tells me which product can flow through which lane. Each one of these lanes for that specific mode of transport has a lead time, and each lane with a specific mode of transport has a transportation capacity. And there are constraints like shipment, multiple, and all that makes my distribution network. So if you look at the RDBMS, this is what you see, which you cannot understand what's happening with it. Now this needs to be converted into this. So this is the ontological schema based on the RDBMS schema that I'm showing. Here you can see that it tells me that location, lane has a location. Location provides the value-added services. Product, a product also goes into the location as a business concept. Location can also be storing the hazardous product. A lane has a mode of transport. Mode of transport can also be lane, ocean, and air. Mode of transport is also dependent upon the vehicle type. Okay, each lane has a status as a constraint. Each lane has a lead time as a constraint. Okay, so this is what I am going to convert from these RDBMS data. This is the data, and this is the knowledge graph that I create, which is easier for someone to understand. It connects the business concepts. As I said earlier, location is a business concept. Lane is a business concept. Mode of transport is a business concept. How do I connect them? Okay, and that's where the knowledge graph comes into play. And if you look at the digital twin of many of the physical assets, you can see these are my machines, and how do I convert them into the ontological schema that reflects the graphical representation of my physical assets? That's how actually it happens. Now, before I take you to the any question, I'm sorry. Okay. So how does the W3C standards using RDB to Onto converts the ontological, creates the ontological schema from the RDBMSs? I have given an example here. So if this was my table, a person is a table, is an RDBMS table, which is bunch of tables and a bunch of rows and columns. So these are my IDs, ID 12, and name is Ellis, and 37, Bob. So it creates the objects here. This object that it creates, a person is an object, and these are the attributes of the object, ID 12 and Alice. So this is how it looks at, and how did it create the person as a class? Because the name of the table was person. So the name of the class becomes the person. So that's how the W3C standards had been defined through the Google research that converts the RDBMSs into the ontological schemas. And here is the syntax of how it can be made in the bottom side. Now, if you are joining few tables, like here is my person table and here is the address. So the same table person here, I'm adding an address table, and an ID is this. My person ID is the so this is the primary key, and this is the foreign key here. So I'm making a primary key foreign key relationships, and here is the address type and address one. So that's how, when I run these W3C standards based RDB to Onto schema creation, it picks up this person as a class, because that's the name of the table, and then it creates the predicate, the address as a predicate, and this is the subject, this is the object, and this is the predicate. So it says that in this address as a class, my ID 5112 belongs to this ID 12 in the person table, and type is home and address is this. So this is how it converts the RDBMSs into the ontological schemas, where the subject, object, and predicates are connected. And the name of the table becomes the name of the class or the business concept that we are trying to portray. So any question about what we saw so far as the presentation is concerned before I go into the system?
I
Okay.
wanted to check in. Earlier, Brian had a question about Neptune, and you said, hang on. Brian, do you feel like your question was answered? I'm not sure what your question was.
Yeah, so your question was the difference between ontological, the ontology and where the graph and the Neptune database comes into play, right?
Yeah, and I think I've got it, and in about 10 minutes I have to jump in, so I'll catch the rest of it in on the recording. But this is great. Carry on. I'm digging this.
Okay.
So let me be expeditious. So these are the MySQL database. This is the workbench where each one of these schemas that you see are reflective of the different transaction processing system, for which I want to understand the semantic richness of the metadata underlying it. So in order for me to do that, there are a bunch of tables in each one of the schema. If I show you carrier, inventory, item location, lane. So these are all logistic tables that I have created. And each one of these schemas have different level of richness within the metadata sets itself. So what I do, I go into the system, and then I run this command. I run these custom algorithms where I'm saying that for this schema logistic domain ontology version 1, this is if you look at this is the schema is logistic domain ontology version 1 in the MySQL database. Find out the ontological richness through the semantic score. So when I run this, it runs this algorithm and tells me that the semantic score for this source of data is 233, and I can run the same for other ones, and it's going to be less than that because I created those schemas and I know they are not as rich as the other ones. So once I know that I need to use the version 1 ontological schema, in order for me to have the highest richness of the metadata sets, metadata richness, I will go to the RDB2 Onto. This is the tool RDB2 Onto. So what I'm doing here, that I'm telling that use this specific database, localhost logistic domain and ontology 1 version 1. This is my database. Use this database and expose entire schema to RDB2 Onto engine and create an OWL file, which is going to be stored in this specific one. Okay. So if I run this, it's going to convert the RDBMS into the ontological schema. It already created this output in here. And if I go to the output folder, here is the output for RDB2 Onto file. If I go to output, it created a version 1 at about 12:28 p.m. about few seconds ago. Okay, so this is the version 1 that it created. So now it created this version 1. How do I view this? First thing is for us to view this ontological schema. So this is the web wall. This is the open source ontological schema visualization tool, and you can see that it extracted the entire ontology and created the relationships between all the business concepts. Okay, and if I go there, like if I go to ontology and select a specific file like this one, open, and if I do upload, it's gonna upload. So I created a OWL file for visualization. Now I need to look at the data within the graph itself, and for that I need to open up the Neptune. Okay, so I go to the Amazon Neptune. I have a Neptune cluster running, and within that I have a specific Jupyter notebook that I'm running right now. And if I show you the Jupyter notebook, this is the Jupyter notebook that I'm using. I'm using a load command to load my OWL file, my RDF file into the Neptune. So Neptune is being used to query the data within my graph using SparkQL. So if I do load here, it's going to ask me a bunch of questions that where is your source file. So if I go to my source S3 bucket, so this is the S3 bucket, and I have to upload this OWL file that I created. I need to upload it. I already uploaded it earlier. I'm not gonna upload it one more time. So you upload your OWL file here from this folder that it created. Once I upload my OWL file into S3, I'm telling the Neptune that I want you to load this OWL file into the notebook. Okay, so for that, I have to go back to the I have to go back and copy the URI, S3 URI. I copy the URI for my OWL file. If I go back and if I paste this URI here, again, I'm just, the file is RDF XML. ARN, the one that I use for this Neptune cluster is this. This is the role that I'm using for this Neptune cluster. And I'm using the oversubscribe. And if I load this, if I click on that, it's loading the OWL file, the RDF file, the graph data file into Neptune now. Okay, so it is loading the graph data into Neptune. Now this is the load ID. And if there were any errors, I can simply find out whether there were errors in the loading itself. So if I run this cell, it's gonna show me that status 200. Okay, so there wasn't any error. And then then using SparkQL within the graph itself, I can find out, okay, what were my total number of shipments. And now if I show you, I only have 2 shipments in my records right now. Okay, so if I run this command, there are, so these it shows me in a tabular format here. So if I show you the output of the graph data, and as I said, every resource in the graph is actually a URI. You can see this is a URI. Okay, so these URI can be shared. You can make these URI available to your trading partners to make your ontology shareable across your entire ecosystem. So this is my graph format, and it captured 2 shipments within my data sets. My carrier is Boyle, estimated delivery date, estimated ship dates. Okay, and so there are so from LX to ORD, this is the product. So these are my shipments. And if I want to see the in a graphical format about the relationship between my this, again, this is not coming up because I'm still working on this. This has to show me that from these warehouse to this distribution center, this product through this more. Like if I click on that, you can see that it shows me shipment 1. If I click on that, it shows me who is the carrier 1. It shows me what is the mode of transport here, mode of transport 5. So it shows me all, but it shows ontology. So I need to still work on that. But the Spark QL query brought 2 shipments from the graph data, showed me in the tabular format as well as the graph format. And it has to show me a meaningful data, which I'm working on right now. Now, if I go back to the ontological schema, this is how it looks like. I am enriching this right now along with the Neptune team within AWS. And this it will look like in next few days, it's going to look like this, where there will be a pretty solid relationship between the transactional data shipment and static data location. And the data will show here in this. Right now, if I go back, it is showing me only the business concepts, and I don't see the graph data here. It shows me the graph data is only available in the tabular format. How do I see the graph data in the graphical format? Like how many units of product is being shipped in this line? I want to see that, and it's a work in process. I'm working with Neptune team to make that happen. Now, one last thing before we call it. Now, if we go back to the PowerPoint slide, once you have the data in Neptune graph, for an example, you can use it for machine learning. So if this data set that I just showed you, if this data set is bunch of features, just assume that these data sets that I extracted from my supply chain knowledge graph has only the business classes and subclasses which are reflective of my machine learning features. Okay, in that case, if these are a bunch of features that you want to work with your machine learning, you simply open up a Neptune ML notebook within the Neptune itself, and this is how it works. I'll show you at a high level. So if you put this graph data into the S3, and if you bring that into if you put this exported data, the graph exports into S3, from the notebook itself, you can spin up a training job using Spark QL. And once the training job is done, the same data sets, the part of this data sets that you want to use for testing your train model, you can send that through a different query, a subset of data as a testing data to test the train model at the endpoint at the train model, and get the inferences out of it. Now, one last point that I wanted to show you now, these data sets, how do I extract these data sets from Neptune? So if you click on this specific endpoint at this port, if you write an API at this endpoint at this port, the entire graph database is going to be available to you for anything that you want to do. You can now create custom applications. You can spin up your machine learning training models. You can do whatever that you need to do. Now, getting back to this, so let's just say that this is the this is a different example that I'm showing. It is not a logistic one, but the important thing is that within the Neptune ML notebook, you can load the data from the graph itself, and then you can spin up the training job. Like I can spin up the training job right from here. Okay, like Neptune ML endpoint create. So I'm creating an endpoint for the inferences to happen, and here is the training, Neptune ML training. So based on those data that I captured in my graph, I can spin up the training job, get the train model, and at the endpoint of the train model, I can send, and then I can create an infrastructure to host the train model, and then send the inference request, like predicting a critic score for movies. Again, this is not a related example. I just wanted to show you a ready-made example whereby the graph data can be used to straight away send it to the machine learning training model, train the model based on their data sets, Once the infrastructure to hosting that endpoint is ready, whatever the testing data sets that you have, you can send it through for the inference to that endpoint for the predictions to happen. So this way you can create, you can extract the data from your RDBMSs. If I go back, you can extract the data from your RDBMSs, select the data that you believe is relevant to your use case, expose them to a custom algorithm that allows you to understand the semantic richness of the metadata. Once you find out the source of information which is rich in the metadata space, expose them to RDB2 Onto to convert that RDBMSs into the ontological schemas, and then use the web owl to view the ontological graphs, and use Neptune to query the graph. And once you have the graph, expose that graph data through an API endpoint that I showed you within the Neptune notebook itself for a machine learning experiment to be launched outside outside the Neptune. Within the Neptune notebook itself, you can use Neptune ML and Spark QL to spin up the training job based on that graph data sets. Once the train model is available, you can spin up the endpoint hosting services to host that train model, and then send the testing data sets from the graph data sets itself for the inferences to happen. So this is in a nutshell the way you can exploit the bunch of open source technologies, as well as the smarter way of creating the semantic richness in order for the graphs to be created. Any question? All right. If you don't have any question, I'll still stay here for a few more minutes.
So have you fed your model into SageMaker?
It depends upon, I mean, I don't need to send it to the SageMaker because Spark QL and Neptune ML itself allows me to spin up the training job. And I'm not 100% sure, but behind the scene, Neptune ML may be calling the SageMaker create training job API. Okay, I'm not 100% sure again. I'm not 100% sure, but as I showed you, just one second, I'll show you that within the notebook itself, you can spin up the training job. Like here is the command, Neptune ML training start, store to, and my training results and training parameters are already defined here. What instance type am I going to be used? Where is the output where the train model is going to be put in S3? What are the hyperparameters? These are the two hyperparameters that I'm spending. So I'm spinning up the training job within the Neptune notebook itself based on the extracted graph data. So I have no need to go to the SageMaker itself. But to address your point straight away, if the number of if the output of the graph data is exactly the number of features that I want to use in the machine learning within SageMaker, then all I have to do is to just ping to this endpoint and get the data out of the notebook. Again, I'm showing you a very small example, but in a normal supply chain scenario, this graph is going to be fairly complex, and the data is going to be fairly complex. You can simply ping this API endpoint at this port, get the data out of it, put that into S3, and then tell the SageMaker create training job API to look at that S3 bucket and start spinning the training job, depending upon what type of a business problem you are trying to solve. Is it a regression? Is it a classification? Is it deep learning business problem? So like image classifications, for an example. So depending upon your machine learning aspirations, you can either use, I don't believe that Neptune ML would be, again, I'm not 100% sure about the integration between Neptune ML and SageMaker. So I will just stop at that.
And what was your original database before you loaded it into Neptune?
Was MySQL here.
Aha, okay.
So if I show you, this is the MySQL, like you can see where my cursor is, MySQL Workbench.
And I guess that could have been just as easily Postgres then.
It can be Postgres, it can be Oracle, it can be, RDS, Aurora, for an example.
Huh.
And I have simplified these three ontological schemas, that these RDBMS schemas that you see here are actually reflecting three different transaction processing system in a typical enterprise environment. But I have just simply simplified it and put it into the same database as a three different schemas, so as to articulate the point, rather than pinging a different database and creating a string and calling and sending a semantic score request. I just created in the same database with different schemas reflecting different transaction processing systems. I think in chat there are questions. Is there any? Okay. All right. Any question? Last one more minute before we stop.